SwayamPrabha. Digital India. Educated India.
Good morning, welcome back to the course on functional conceptual design. So, in the last class we briefly introduced about the product architecture. From the functional design we moved to the design of the product in terms of its architecture, where we try to map the product functions into product form. So, that is what the architecture is, and we found that the creation of architecture has got a lot of influence in the design of the product, and there are two types of architectures we normally encounter. The first one is known as the portfolio architecture, and then the second one is the product architecture itself. So, that is what we saw. So, portfolio architecture talks about the family of products, I mean how many products should be there in the product family, and product architecture talks about how to architect an individual product. So, that actually depends on the number of products in the family also. So, these two are interconnected. You need to design the architecture of the product based on the number of products in the family and how do you want these products to share the components. So, we look into these two aspects of the product development, which is the product portfolio architecture and product architecture. And yesterday I briefly showed these kind of products also, that you have a set of products like this, where you can see each product is independent of the other one. There is nothing common to these products. The handle is different, the tool tip is different, and each one is an independent product. But in the case of this kind of products, you can see this is a toaster, where you have a toaster with two size of two breads can be toasted, or here it can be have 4. So, they are two independent. You can see there are two products. So, a customer can decide to go for a 2 slice or a 4 slice toaster. However, when the designing the product, he need to see how best he can utilize the resources in order to get these products. For example, if you have to make both the products completely different, then the cost of production, the cost of design, cost of manufacturing, everything will go up. But you can actually have many things common to both the products, and therefore, by properly designing the architecture of these two products, you will be able to make the products very cost effective, and at the same time you can have variety in the product availability also. And here you can see a kind of film rolls, where you can have the number of films available in each roll can be different, and there can be many things common. The outer cover can be the same, the center portion can be the same, but still you can have products variety in the market. So, this is the way how any manufacturer will provide variety in the market, but how many products to be offered and how do we decide the individual specification of each product or within the family, all matters a lot when it comes to the market and then satisfying the customer requirement. That is why the architecture becomes very important. So, whether to have many products in the family or can have only just one product, and then how this product need to be architected, all matters a lot. So, that is why we have these two architectures, portfolio architecture and product architecture need to be understood. So, I mentioned this portfolio means a set of different products that a company provides, and architecture is the layout of the components. So, how you lay out the components within the product is basically the architecture, and the set of different products that a company provides is the portfolio. Now, what actually decides this portfolio architecture is the cost and revenue. So, how much will be the revenue that you can generate and how much each product can cost, that actually decides how many products to be offered in the market, because if the requirement is very small, there is only very small number of customers for a particular variety of product, then there is no point in developing a product for that particular customer segment, because the cost and revenue won't work out well. So, this need to be understood before we decide how many products to be there in the family. And product portfolio architecture is the system design strategy for laying out components and systems on multiple products to best satisfy current and future needs. So, we have multiple products in the portfolio architecture. So, in these multiple products, how best we can arrange the components, keeping in mind the current requirements of the customer, because currently there will be some requirement for the customer, but after 1 year customer requirement may change. So, we need to keep this also in mind when we do for the portfolio architecture, so that after 2 years we will be able to easily modify the product to meet the customer requirement. So, the current requirements as well as the future requirements need to be taken into account when we decide the number of products in the family and the architecture of the product. So, the design task here is to determine whether one might develop subsystems within the products that can be reused across different products. So, the question is, can we have some kind of subsystems in a product, so that this subsystem can be used in multiple products, so that you do not need to separately develop for each product within the family. So, we can have some kind of subsystem which or some subsystem can be made common to all those members in the family, so that it can easily make the product and sell in the market. So, few things will change, but many things can be the same for all the products, and therefore, you will be able to offer variety without much difficulty. So, that these are the things to be understood when we look for the portfolio architecture. So, first we will look the type of architectures existing in the portfolio, or what are the ways in which portfolio architecture is classified, and how one can decide what kind of an architecture to be used for the portfolio or the family of products. So, that is what we are going to see. Now, if you look at the portfolio architecture as a whole, you can actually classify them into 3 major categories. That is, the first one is known as a fixed unshared architecture. The second one is a modular platform, and the third one is known as massively customizable. So, these are the 3 major categories of portfolio architecture existing in the current market. And many times this will be used, but some of them will be preferred over the other, considering the particular product and its specific characteristics, but most of them will be always following a particular architecture called modular platform. But let us just look at the first category, which is the fixed unshared architecture. So, if a company decides to make 5 products to bring to the market, and if they feel that okay, all these 5 can be offered in the market and there need not be anything sharing between these 5 products, and that kind of architecture is known as a fixed unshared architecture. So, the family will be having many products, but these products will not be having anything in common. Each one will be independent, and it will be having its own components which is not shared with any other product within the family. That kind of an architecture is known as a fixed unshared architecture. A typical example is this screwdriver set. You can see this screwdriver has got its own handle and the tool tip also, and here also it has got its own handle, and which is different from this one, and this tool also different. Similarly, this is different from this one is different from this one is different from this one. So, each one is completely independent. There is nothing sharing between these products, and that kind of an architecture is known as fixed unshared architecture. That means you have products in the family, but the products do not share anything between themselves, is known as the fixed unshared architecture. One of the typical example is this one, and like that you can see many products in the like hammer sets or spanner sets you will be seeing in the market. So, there will be many such products which actually go for fixed unshared architecture. A company can go for this kind of architecture only if there is a large demand for the product, because if this product has to be made, if they can make it in thousands, they do not mind going for a design for this one, a special design for this and a special design for this, because they can make large numbers and the cost of manufacture per unit will be less. But if the requirement is only some 10 or 15 or each one of these, then making each one separate will be very costly, and therefore a fixed unshared architecture is opted only if there is a large demand for this product. So, that is the fixed unshared architecture. So, whenever there is a large demand for this product, we will go for the fixed unshared architecture. And in this in itself, you can actually have two categories known as single offer and robust offer. In the fixed unshared itself, you can have a single offer and a robust offer. So, basically it says that in fixed unshared it is a single offer, there is only one type of products in the market, there is no variation to that, all over the world it will be the same. So, there is no variation in that. But robust offer, still if it is in a fixed unshared architecture, in the robust offer it may provide you some kind of flexibility in the market to meet some specific requirements. For example, if you have a power supply unit where you want to connect to the wall sockets, you need to have some variation between the countries. So, if you use something in India, you will be having this 3 pin configuration, but if you use it in some other countries, it may be 2 pin, or the pin will be different in other countries. Even if it is 3 pin, the pin geometry will be different. So, to that extent there will be variation, and that kind of offers are known as robust offer. So, these are the two variations that can be there in the fixed unshared architecture. So, there is no common module and it is high volume for fixed unshared, and the screwdrivers, magnetic assets are examples for this, and the fixed unshared single offer does not take into account market variation. So, if it is a single offer one, it will not really take care of the market variation, and they assume that every market can actually take this and then sell it as a product. But the robust offer will take some variation that take into account some market variation, especially the power sockets and other things in the electric sockets, power supply, etc. in the product. That is the example for robust offer. So, this is not a very commonly used architecture. The fixed unshared is very rarely used, especially when there is a high volume requirement for a product, then they can go for a fixed unshared architecture, because that is cost effective, the cost and revenue matches in this case, or you can still make good profit. But when that is not there, when the volume is very small or not worth going for a fixed unshared architecture, then we need to go for the modular architecture. So, that is the second architecture, which is the modular platform. So, let us say this one. So, as I mentioned, the different products do not share any components in the fixed unshared architecture, and these are the examples for the fixed unshared architecture, screwdrivers and spanner sets, etc. You can see that is an example for fixed unshared architecture. In the modular architecture, as you can see, the modular, the name itself says that it can be have modules. So, a product will be having multiple modules, and then these modules can be shared within the family, and that kind of an architecture is known as modular architecture. So, if there are 5 products in the family and a company decides to have 5 variants of a car in the markets, for example, if Hyundai or Honda City wants to have 5 types of city models in the market. So, they cannot have each car as completely independent, because that is not cost effective, because each model is the number of units they can sell will be very limited. So, what they do, they make the modules within each one will be having multiple modules, each product will be having multiple modules, and many of these modules will be shared among the models, and only few things will change in the between the model. Still you can have different models in the market, but there will be many common things in the in these products. So, that kind of an architecture is known as modular architecture. So, this is the most commonly used architecture in the portfolio development. They will see what are the modules that you can actually develop separately and then can be shared among the family members. And in this one itself, there can be different variants also, because as I mentioned, the product should look at the current requirements of the customer, because currently customer will be having some cost requirement, some performance requirement, some safety requirements, etc. But after 2 years their preferences will change. Now, After 2 years, if they have to meet the customer requirement, they cannot again go for designing a completely new product. So, they have to build upon the existing product and then make it suitable for the customer after 2 years. So, they have to keep that in mind, what are the things that is going to change in the future. So, that also need to be taken into account when they design the modules within the product. So, that is one requirement. Similarly, there will be products which may require something which will be consumed very often. So, they need to make that as a module, and that only can be changed, or that consumable can actually be made different for different product. So, this way you will be getting different architectures for the product. So, the modular architecture can be divided further into categories like a modular family, a modular generation, modular consumable, modular standard, and modular parametric. So, these are the different categories within the modular family that you can see. We will see each one, what is the significance of each of these architectures. So, the modular family, okay, so let me see. So, the modular family is a series of products that share some modules. So, that is the simple explanation for a modular family. So, in most of these there will be a basic platform, and on the basic platform you will add many modules. So, car will be having a chassis, and then you will be having a module for the transmission, a module for the engine, a module for the air conditioning, a module for the steering system, and a module for the dashboard and things like that. So, each one can actually be having a module. So, you will be having many modules in the product, and these modules will be shared amongst the models within the family. So, if you buy a Cia's high end car or a low end car, there will be many things common in both these cars, and very few things will be different. So, this way, if they can actually share the modules, software and hardware, then we call this as the modular family of products. So, that is known as the modular family, where the modules are shared amongst the family members. That kind of an architecture is known as modular family. For example, you take this coffee maker. So, this company is actually offering, this Krupp's company is offering 2 products in the market. So, somebody who is interested in going for a very high end, very nice product with a lot of electronic controls and all, they will actually opt for this one. And somebody who is looking for a low end product, they just want the function to be there, coffee to be made, they do not really care for the appearance and other things, then there is a product for them. So, this product can be cheaper one, this can be a costly one. Now, if the company has to offer these 2 products, if they make it completely independent, then there will be a lot of cost involved in the production. So, what they will do, they will many things they will make common. So, probably inside the heating element or the container and the way the container is assembled, those things may be the same, but the control and the display, the control knobs, display, these things can actually be made different, then you will be getting a different product. So, many things will be shared within these products, but still the product will be different for the customer. So, that kind of an architecture is the modular family architecture. And you will see a large number of products in the market is actually belonging to this modular family, whether it is your washing machine, mobile phone, television sets, any product you take, you will see that there are many product variants available in the market, and most of these variants will be having many things common within the product architecture. So, that kind of a architecture is known as the modular family architecture. Now, so these are examples for the modular architectures. You can see all these products will be having a lot of things shared amongst themselves. So, this toaster, if you look at this toasting element or the heating element will be common for these, except that they are actually combined them and made it into a separate one, and then a little bit of change in the control and other things will give you a different product with a 4 slice capacity, and this will be a 2 slice capacity. So, a customer who is looking for a 2 slice, he can actually buy for low cost, and somebody wants a 4 slice one, they can actually get it by paying some extra, but the manufacturer need not make everything completely separate, because they will be sharing many of these things between these 2 products, and that is the case with most of these products, your camera, mobile phone, iPad and printers. So, all those things will be able to see this kind of sharing of modules. So, that is the modular family architecture. Okay. So, the set of products that are supported at any one of the time by a platform. So, always all these products will be having a common platform, supported by a common platform, and to that they will add the modules. So, by changing some modules you will get a new product, but the basic platform will be almost the same. So, that is how most of the companies or manufacturers able to bring multiple products in the market, because the common platform they will keep add modules, and some modules will be different compared to the other product, so that you will get a variation in the product variety. And so, here you can actually have different derivative for the product. By using a modular family architecture, you will be able to create the variants of the product. You can actually have a cost variant, that is you want to have a low cost and a high cost product. So, the low cost you can actually have some kind of some modules can actually be changed, so that the cost will come down, and if you are looking for a high cost one, you can actually change the module with a high cost element or high quality elements can be used to get a costly product. And that is possible because these are all modules. So, modules can be changed without changing the whole product. Some critical modules can be changed to make it a better product and a cost variant. And you can have product line extensions if you want to have like 2 slice, 4 slice or bigger size. Like washing machines, you can have different capacity washing machines. Many things can be common, but only the motor and the drum size and things can be changed to get a various capabilities or capacities. That is the product line extension. This is basically to meet the customer needs, because there will be customers who are asking for various they will be having various requirements, and by providing this kind of variants you will be able to satisfy those customers. And additional features to address more difficult customers. Some customers may require very specific needs. So, we can actually add those needs or those modules into the product and then make it a very enhanced product or a high end product for the customers. So, these are the ways in which actually you can provide multiple products in the market without changing the basic platform and without having it as completely new product. You can change the modules and then modify the product to get a different a variant of this product, and that is how the manufacturers are able to offer multiple products in the family. So, this is one of the most commonly used architecture, modular family. And the next one is basically known as the modular generations. It is also a kind of modular product only. So, in this case we are not looking at the products currently to be offered in the market, because modular family looks at how many products I need to offer currently in the market. So, if a company is trying to introduce a new washing machine in the market, they need to see what kind of variants that we can offer in the market, so that a large customer segment will be happy in terms of cost, in terms of capacities, in terms of water consumption or whatever it is. They can actually offer different variants of the product using the modular family. But modular generation is looking slightly in a different way. They are looking now I can offer 5 products in the market, but then after 2 years if I have to offer the product, can I offer the same product or I need to change it completely? What will be the changes in the customers preferences over the period of maybe 2 years or 3 years depending on the product. Now, if the company can offer a new product in the market to meet the customer requirement at that point of time after 2 years, can we use the same platform and the same product, change a module in order to meet the customer requirement? So, by looking at what is going to change in the future, you make that as a module and then make sure that if you want to offer a new product in the market, you can actually change this module and insert a new module and then bring it as a product, so that customers will be happy at that point of time. So, that is what actually happens in most of the electronic products, because if they offer a product today in the market, after 1 year people will be looking for better features in the product. So, you can see each subsequent model enhances only some subset of the modules of the previous generation. So, some modules in the previous generation will be modified to meet the customer requirements of the current generation. That is known as the modular generation architecture. So, typical examples are the cameras and other electronic products, because today there will be an LCD display and after 2 years the display may be changing to something else, and then people will be looking for that kind of a display in the product. So, the company cannot scrap the whole product and then make a new product. So, they can actually have only the display module can actually be changed to a new technology, so that they will be able to offer a product which actually meets the requirement of that generation. So, that is the where how actually the processor capacities, the RAM capacities etc. are actually added to the system, so that that system will meet the requirement of that particular generation. So, this is known as the modular generation architecture. So, if there is going to change something in the future, then we need to think of a modular generation architecture. There are not many changes expected, then we go for a modular family architecture. So, this module family is normally employed in automobiles and such products, where actually the changes are not so drastic. Every year there will not be too much of changes in the technology or the expectations of the customer. So, they can actually go for modular family, but in the case of electronic products, most of the time they need to keep this in mind and then go for modular generation architectures, so that they can meet the expectations of the next generation or after 2 or 3 years. So, that is the modular generation architecture. And the third one is known as the modular consumable architecture. Okay. Here the architecture differentiates modules based on consumable or not. So, it is a very small number of products which actually fall into this category. Suppose there is a product and there are some consumables coming in the product, and this consumable may change depending on the region or depending on the situation, then we can actually make that as a module and then offer the product with this consumable as a separate module. So, that kind of an architecture is known as consumable module. For example, the printer, the toner is a consumable in this case. So, they will make this as a module, so that you can actually attach any kind of compatible consumables to this product, and even if there is a change in the consumables use, you will still offer this product by changing the consumable and by making sure that this consumable can actually go into the product, you will be able to offer the product. So, that is known as the modular consumable architecture. This ink cartridges for inkjet printers, film for film cameras etc. are the consumables architecture. And the next one is the standard architecture. So, standard architecture is basically to look at the current standards of manufacturing and design. So, there will be lot of standards followed by industry in making products, that is the communication standards, interface standards, and standards for connecting hardware to software and things like that. So, we need to follow these architectures, these standards in the product. So, whenever there is a standard available for a particular product or a particular component, we will try to ensure that this product meets that standard, and then we will make that part as a module. So, that whenever there is a change in standard or there is a need to change this component with a different component which actually meets the same standard, we should be able to modify the product as per the requirement of standard, and that is known as the modular standard architecture. So, we follow the published standard in interfaces, mechanical, electrical and software interfaces, and then make sure that this product meets the standards of industry standards, so that any product or any component which meets the standard can actually be interfaced. For example, the lens mount system in the cameras. So, you can actually the camera structure will be there and you can actually mount the lens. So, these are actually having lot of standards in this design of such lens and mounts. So, whenever there is a compatible component which actually meet the same standard, we can easily attach to this product, and then it can be used as a can be used to meet the requirement of the customer. So, that is the modular standard architecture. Okay. So, this is also not I mean this most of the companies need to follow this, but that will be coming from the existing standards. So, more than the customer's requirement, this is coming from the industry standards. And the last one in this one is known as the parametric modular parametric. Modular parametric is nothing but by changing the modules parametrically, and fit into the product at the time they are ordered. So, this is basically a customer requires a particular size or the shape of a component or a product. So, you can modify the existing modules to meet that particular parametric limitations and then fit into the product. So, that is known as the modular parametric. So, in the case of a computer, a customer will say, okay, I need to have a particular size of the product, overall product I want this much only, and I want to have a particular hard disk capacity, a particular RAM capacity, etc., etc. So, depending on those parametric requirements, you can actually fit those modules into the main platform and then generate the product. So, that is the modular parametric design. So, these are the 5 categories of modular family architecture, which is basically used for the portfolio design. And as you saw, this actually is modular family is the most commonly used one, and modular generation is considered whenever there is a expected change in some of the requirement of the customer over a period of time, and others are depending on the product's architecture rather than the customer's requirement. Of course, customer requirement also play a role, but it is more from the designer's point of view offer this kind of architectures. So, that is the modular architecture for portfolio design. I hope you are able to follow, and in case you have any questions, please feel free to email me or ask me whenever we get an opportunity. Okay, the last category in this one is known as the customized one. So, customized is a product which is actually customized to the requirement of a customer, that is basically the customized architecture. So, it is we are not going to offer too many products in the family as directly to in the market, but look at the customer, and if the customer is asking for a particular kind of architecture or particular product with some particular features, then you try to offer that as a product, one time offer of a product, and that kind of architecture is known as customized architecture. Only very few products offer this kind of architecture, especially when there are very high end products, like you want to have a high end car, and especially companies like BMW and all, they offer customized car. You can actually tell what actually you are expecting from your car. You can tell the color, you can tell the engine capacity, the speed requirements, etc., etc. And based on all these things, they will actually create the product and give it to you. So, they will be having a basic platform, and they will be having different modules to attach, and then depending on the customer's requirement, they will add these modules and give you the product. So, that is basically known as the customized architecture. So, in this one there are 2 types, one is known as the bespoke and the other one is the parametric. So, bespoke is that the product designed and made based on the customer's provided engineering specification. So, the engineering specifications are given by the customer, then you give that design the product accordingly and give, that is known as the bespoke product. So, these kind of things normally happen in very high end products, or something like fighter aircraft. A country wants a fighter aircraft with a specific requirement, and they will give all those engineering specifications and then give this to the company and tell that, okay, now these are the specifications we are looking for, make one and give it to us. So, that is the customized design for a product, and that is known as bespoke design. The other one is parametric. Parametric is that the company has got many modules of various size, various dimension, various capabilities, various parameters. So, the customer can say, okay, oh, my engine capacity should be this much, and then they will say, okay, my overall length and size should be this much, my seating capacity should be this way, and my steering characteristic should be like this. So, I need a power steering, or I need a manual steering. So, this way they can actually say, okay, these are the requirements, and company has got these modules. They have a power steering module, they have manual module, and they have a engine capacity, various engine capacities available. So based on all these, they use from the existing modules, they choose the module and assemble and give it. That is known as the parametric design for the customized platform. So the first one is more on there are no modules available with the manufacturer as per the requirement. The customer will give the engineering specification and the manufacturer will make accordingly and then give it. That is the customized bespoke architecture. But in the parametric, customer will choose from the existing modules and then get the product. That is the customized parametric design. So customer configures product by selecting a series of different modules that make up the product. So example, computer also, many times we tell the computer supplier or the manufacturer, okay, these are my requirements, and I mean they will be giving different options for a computer, and then you choose, okay, these are my options, then they will actually based on that they will make the product and give it to you. So that is the parametric architecture, customized parametric architecture for portfolio. All right, so that's all the portfolio architectures. So customized, we already saw this. So the car can actually be designed based on the customer's choice of various modules, and then they will assemble it and give it to you. So that is the customized one. Okay, now we saw these are the main architectures available. So you can have a unshared architecture where there is no sharing of modules or components between the products. Then you can have a modular architecture where there will be a lot of sharing of modules between the products, and within the products these modules can actually be the modular architecture. Within the modular architecture you can have different ways of getting the modular architecture, either by modular family or modular generations or modular consumable, like that. Now the big question is that okay, how can I decide about this architecture? So what actually the criteria for choosing an architecture, on what basis a company can decide to go for a modular family or modular generation or a completely unshared architecture. So this is the question for the designers. So the designer has to take this decision, though the data comes from the customer, and finally the designer is the one who actually decides how many products can be offered, what should be the way this product should be architected, that is what way the elements in the product can be arranged so that we can have that many products, but it meets the customer's expectation. So as I told you, this is it actually is the result of market dynamics. When I say market dynamics, it actually involves the cost of the product, the number of units that can be sold, and the changes in the market segments, and how fast the market is growing, or how fast the market is changing with respect to time, with respect to the design parameters or the customer requirements. So all those is actually affecting the choosing of portfolio. And we know that there are a variety of different customers, and a customer is asking for variety. So any product you take, and if you want this to be sold in the market, you will see that there are large variety of customers. The customer will be having or customers can be segmented based on various criteria. You can actually see that, okay, there are young customers, there are old customers, or there are children who buy the product, or the customers can be segmented. Okay, housewives will be preferring something, college going people will be preferring something, adults will be adult male will be preferring something else. So like that you can actually see there are a lot of variety of customers in the market, and each customer will be actually asking for variety. So today they will be asking for something, tomorrow they will be asking for something. So there will be a lot of variations in their preferences also. So how do we actually meet these requirements, how do we actually address the requirements of varied customers and customers asking for different varieties? So one way to look at this is to see what is the distribution of the customer requirements across the population. That is, you have a large set of customer population. Say there are, for example, you will say there are 1000 people you can identify for a particular product. Now, you have to find out what is the target values or how the target values are distributed within the population. Take a simple case of mobile phone. You ask 10,000 people, okay, what will be the approximate cost you are ready to pay for this product. So, that is one target value is the cost of the product. If you ask this population, you will actually see that there is a large variation. So, it cannot be a single value. So, there will be a large variation, and then you need to see how these target values are distributed over a period distributed within the population. So, that is one criteria that you can use, and then you have to see a time distribution, how the customer uses over a period of time. So, today there is some requirement, and maybe after 6 months their requirement will be changing. So, in what way the customer preferences are changing over a period of time, and then using this information you can use an architecture selection flow chart. So, you can use an architecture selection flow chart to select what kind of architecture to be used for this particular product. So, that is the way how a designer can decide which architecture to be used and how many products to be offered in the market for that particular family. So, this is the next step that we have to do. So, first we need to go for a population distribution of target values, and then we need to look for a time distribution of target values, and then we use a selection flow chart to get the architecture to be used. Okay, so, we will see this in the next class, how do we actually use a selection flow chart to decide on the type of architecture to be used for the portfolio. We will discuss in the next class. Okay, thank you very much. We will meet you tomorrow.